Hi everyone, Audrow here. Isn't it amazing how far Tesla gets in their self-driving by leveraging vision? Vision is a powerful sense. There's a lot of information there, but it's a lot of work. From designing the hardware to routing the data to running AI and algorithms and syncing with other sensors. That's where today's guest, Luxonis, comes in. Luxonis makes vision platforms that solve a lot of the hard problems I mentioned. And increasingly, they're handling more of the on-device compute, with vision sensors, some other sensors, and compute being put on one device. This is super exciting for edge applications like most robots. I talk with Luxonis' CEO, Bradley Dillon. You'll like this episode if you're someone building robots on your own or part of a company that has robots in places where seeing would be valuable. Or if you're curious about the state of computer vision in robotics. This is the second full interview that I've done with Bradley. It's very cool to see how much progress they've made in the last couple of years. I think Luxonis is making a great platform, and that having companies like Luxonis makes it easier to just get something off the shelf that works to build your robot without having to be an expert in cameras and all of the other related engineering. This isn't dissimilar in my mind to what we do in software development when we use libraries like Eigen for linear algebra, TensorFlow for machine learning, or 3JS for 3D visualization. You can just use them without solving all of the underlying hard problems that they solve already. Anyway, make yourself comfortable, and here's my conversation with Bradley Dillon. Hi, Bradley. Would you introduce yourself?
Hi, my name is Bradley Dillon. I'm the CEO at Luxonis.
Awesome. Tell me a bit about Luxonis. What's the mission? How large are you guys? How long has the company been going?
Yeah, great question. So we were founded back in 2019, so we're coming up on our 6th birthday. And what we do is we provide artificial intelligence-enabled cameras. And what these cameras do is they help things like robots be able to see and navigate the world. So we're trying to be basically the eyes and the ears and the brain behind these robots. So you can basically think of us as being kind of the visual cortex. And, for us in our, startup journey, we have scaled up a lot. So we've sold more than 150,000 of these AI-enabled cameras.
Amazing.
Yeah, it's been quite the journey for sure. And we're up to a team of about 80 people, 100 people, and 80 of those people are engineers. And yeah, that's kind of a brief overview of the company.
Now, you said 6 years. Tell me about kind of the trajectory of the company and kind of how things are changing, like your focus, I suppose, how it's changed over the last years. Because I know you guys are going in an exciting direction.
So things have definitely changed a lot. In the first few years as a company, and not really that very like 0 to 1 time frame, it was all about being able to nail the hardware and firmware. And so we got off the ground by doing a couple of Kickstarter campaigns. And so we were able to kind of crowdfund our idea. The idea was that you could have this low cost and performant, 3D stereo camera, that could help, robots navigate and see in the world, and that you could do it in a way that could actually have, artificial intelligence on it. So, and we were in that first few year period with a small team, 5 to 10 people, and the biggest obstacles were really on the firmware side of things. So first off, it was getting being able to abstract the hardware to make it so that you could have meaningful software that our customers could use. And then the next part of our journey was, how the heck do you do manufacturing? And we grew up for the first time, procuring and building products in the midst of probably the craziest, semiconductor electronic supply, shortage and insanity that, the world has seen this century. And so that was during kind of in the post-COVID times. And so we had to figure out, how do you actually build, tens of thousands of these devices in a reliable way? So that was really the first few years of the journey. And in the last few years of the journey, what we've done is we've started to build on top of that backbone, the hardware and firmware being our backbone. And so that means is we've started to really work with businesses tackling, specific industry-specific use cases, and get it to where our type of equipment is able to be deployed at scale. And so initially we were more focused on kind of the hobbyist, consumer hobbyist use case. And that's how we kind of initially started. But now our entire focus is on, the B2B, business to business type of applications that are out there. So as a company, as you can imagine, we've had a transition to where, things like reliability and stability become really important. So we've had to start to, care and invest more in quality, manufacturing operations, things like that. And then we've also started to verticalize our product, meaning that there's, software that can sit on top of it that can solve those, industry use cases, like I mentioned. So that's a bit of the journey. It's, startup life is definitely a roller coaster. But that's kind of the main transition, kind of in the last 6 years.
Mm-hmm. And where are you guys at in terms of, are you taking investments? Are you cash flow, like earning good cash flow from all the sales, or how are you guys funded, I suppose?
So we have been funded by kind of bootstrapped plus friends and family. So, personally,
Wow.
Yeah, it's crazy to be 6 years deep doing that. So personally,
Yeah.
I've invested twice. I've had 8 of my friends and family who've invested as well. And, it makes things like, say, going to a wedding a little bit awkward because they want to know how their money's doing. So we have, luckily, this great network of angels. And some of these angels have cut, bigger tickets to invest in us. And that's been able to get us to where we're at today. So we've had to be very scrappy to be able to do that and, actually, build and have hardware inventory. And then as we look ahead, we are considering all options. We potentially would be looking to do a fundraise in the, not so distant future. But, financially, we're doing well. We're not quite currently, profitable or cash flow positive, but we're relatively close. It's really just that we have so much things that we're so excited to develop from a product development perspective that, we keep just plowing, every available dollar we can justify into building for the future. But the company is very stable from a financial perspective.
Mm-hmm. Yeah, that's awesome to hear. That's absolutely wild that you've made it this far on family and friends and some individual angel investors. Do you think if you were to go for investment, would it be like an A round or a B round or something? Because it sounds like I think you have pretty good traction. You've kind of skipped a little bit, but how do you think of it?
Yeah, it's funny. The amount raised in, Series A and B rounds has changed so much over the last 5 to 10 years. So, a Series A that used to maybe have been, $5 million, that maybe is now kind of $25 million. So,
yeah, I know.
Yeah, it's funny how that's happened. But yeah, I mean, probably in the venture capital world, you would call it, probably a Series A, and you would, the terms are kind of funny, but you'd say maybe we've previously done like a pre-seed, a seed, and a pre-Series A. Something along those lines. But yeah, it would be a larger institutional raise that would be, raising a, more significant chunk of capital and likely on the kind of venture capital side of institutional investors.
Okay, very interesting. Super exciting that you guys are there. Funding by that way, and have been scrappy to get there. I really like that. I want to talk more about that a bit later. But tell me about your equipment. Tell me about your cameras. Tell me about how they generally work and what kinds of sensors you support.
Yeah, absolutely. So I'll hold up for any of your audience that maybe is, watching the video stream here. This is an example of one of our cameras right here. And I'll hold it up to my eyes and start with to say, if you can kind of see, there's a left camera and a right camera. And it's actually, we designed it as exactly the width of our human eyes. And so
cool.
Our thinking was, for some reason we evolved to have human eyes that were, this far apart. So might as well just pick that for these stereo cameras. So from a sensor perspective, the first big thing is the left camera and the right camera. That data is fused together, and it makes it so that you can create a 3D map of the world in front of you. So it makes it so that you can understand, okay, this laptop screen is, 15 inches away from me. And then from a sensor perspective, we also have there's another camera here at the center, maybe a little hard to see, and that's a really high resolution camera. So this would be something that would be, as high resolution as the latest and greatest iPhone. So it'd be, our latest models, it's like 48 megapixels. So it's a really high resolution. And we're pushing the boundaries there too. Our newest hardware can support up to 108 megapixels. And so what's pretty incredible about the journey there on pixels is they say that the human eye has about, 500-600 megapixels. And so it won't be too long before we'll basically be able to have cameras that, have higher resolution than our human eyes, which is pretty incredible to think about. And then to continue on purpose.
We probably do have cameras that are higher resolution than the human eye, I would think, but it's not in a small form factor. Is it true, or?
That's right. Yeah, it's not. So we support kind of sensors that we can, manufacture at scale that, at an economic price. And so there are cameras, like you mentioned, that do go that high. And it's really for, probably another 4 years in our journey, we'd be able to offer that, I would say, with our platform based on the, the cost curve and the way things are progressing.
So exciting.
Yeah, it's really incredibly exciting for sure. And then some other sensors on these products is, so there's some infrared here. And the infrared, what it does is that two things. One is it's infrared illumination, and that's basically night vision. So it makes it so that if you're at night, you can still operate with it. And then there's this thing called an infrared laser dot projector, and that's for something that's called active stereo. And what that does is it basically, you can imagine it spray paints a bunch of dots on a surface. And sometimes if you're like looking at a white wall, you get kind of woozy because you can't tell how far it is. You kind of get, your mind gets kind of warped out. So this does, the infrared laser dot projector makes it so that you get texture on that surface and you can actually see how far it is. And then on the inside of the device, we have additional sensors. So we have like IMUs, so that's an inertial moment unit. And what that does is it, measures, basically can measure like the pitch, yaw, and roll, and measure how things are moving. So that's the thing, like on your iPhone, where, it knows that when you turn it sideways, it knows to like, turn your screen sideways. And then we have some other new sensors as well that we're excited about. So we have our first thermal sensor, and then we have also our first LiDAR-based sensor, and that's basically where a bunch of light is shot off, and then it bounces back, and then based on how much time it takes for that to happen, it can create a nice 3D, high precision model of things. So yeah, we're a full sensor stack. Last one I forgot to mention is microphones. So these are an incredible amount of sensors that are all fusing the data together on the edge, which is really exciting.
Mm-hmm. Do you have is the thermal camera? So my video is a bit jagged, so I can't always see everything you're holding up, but the it's like stop and go. But the thermal camera, is that on one of the, do you have all of the sensors you mentioned on one device, or is it that there's like a dedicated thermal camera?
Oh, we have a dedicated thermal camera. So I'm holding it up here.
I see it now. Okay.
Yeah, so this one that kind of looks like it's reflecting like a mirror, that's the actual thermal sensor. And then we have a high resolution color camera. And so then that data is able to be fused together. So yeah, it's a dedicated product.
That's so cool. Okay, and so with all of these sensors that you have, I guess it's very interesting that you have so many different types of sensors. The microphone, the IMU for figuring out how it's tilted. Tell me a bit about having all of those sensors, because it's going more from like being a vision sensor to being a sensor node, or something like that, like a little platform you strap on that has everything. Tell me about that, because it's interesting that you're integrating so many different types of sensors.
Yeah, so it's a great question, and it kind of is at the heart of one of our durable product strategies. And so one of our long-term strategies that we're really bought into is that we want to be supporting new sensors every year and more performance sensors for the existing ones that we have in the lineup. What we hear from our customers is that when you have to have an array of different sensors that come from different providers and different systems and different setups, it's really difficult to manage those. And so by integrating them all into one device, it really makes things a lot easier to be able to operate. It makes it so that you can really fuse that data together. It makes it so that you know exactly from a timing perspective on when are you getting each piece of data. Where if you're trying to synchronize that across different devices, it's really hard to get that to be done in a really low latency, really high performance type of case. And we believe that by having doing the painful thing of constantly adding these new drivers to support all these sensors, that we're making it easier for our clients, because they can just buy a device that's your all-in-one sensor device. And then from a more abstract perspective, we're ultimately, in a lot of cases, we're competing with humans. Humans maybe would have been the ones that were, doing a type of task before. And so we want these systems to be able to compete with humans. And that means that you have sensors that, can do some of what humans can, but then you can add additional ones where you basically can imagine a human, but they have superpowers, right? So, humans, don't have a thermal sensor. We can't, look at something and know how hot or cold it is. But you add it to our device and you can. And so that's pretty exciting for us to be able to unlock these use cases that these sensors can provide to our clients.
Mm-hmm. Yeah, I like that perspective a lot. And with the thing brought in, which is just how crazy large the labor shortages are across lots of industries. And that makes it so that there's a very good reason to try to get robots or some sort of automation to be replacing humans or just providing work where there are no humans for all this. Like that's a thing that I think is often, I don't know, should be thrown in there because there is some fear around taking all the jobs. I think like robots taking all the jobs of people.
It's a great topic, a great point. It's something that we talk a lot about and something that we're pretty passionate about. Our perspective is that these, robotics and automation systems are going to, make the world a much better place. And the reason for it is that there, as you mentioned, in a lot of the rich world, labor has gotten more scarce, and people that are doing physical labor. And what these types of robotics and automation systems do is they're able to take the most kind of like mind-numbing, repetitive, dangerous tasks. They're able to take that off from the human. And what they do then is they're able to make it so that collectively the world can become a more productive and in a richer place. And so you've seen this throughout, technology history over the last couple hundred years, that each new wave of technology, what it is it's very deflationary. So it makes it so that we can be more efficient and more productive. And then what that does is then it, that makes it so that there's excess capital gets formed, that excess capital gets invested into new things, to new investments and new innovation, and the world, keeps having more and more jobs. And the example I like to use is I got to recently visit South Korea, and in South Korea, they actually have 5 times more robots per human than any other country in the world. It's like walking into the future.
Amazing.
And so at the airport, they have robots helping with things. I went to a restaurant where they had the food brought to our table and taken from our table by a robot, and the dishes were cleaned by a robot. And I don't think anybody in that restaurant is saying, I'm really upset. I really wanted to wash the dishes right now. And instead, that employee can say, oh, I can try to maybe go and improve the client experience. I can go try to upsell them and have a better, personal touch. And the owner of that restaurant, they can pay their workers more, and they can, use that excess savings to maybe expand, et cetera, et cetera. So we think it's an incredible positive thing. And we know I think it's easy sometimes to think, oh yeah, we believe in tech history. We know what happened before, but this time is different. And I don't think this time is different. I think it's another way that's going to be very similar, and I think it's going to make humanity and the world a better place.
Totally. I think this time is a little different in that demographically we're in a way that the world hasn't been in the past when we have increasing technologies, which is we have in most of the rich world, say, there's a lot of older people, and that's kind of a new thing. And so there's a lot of people leaving the workforce and a lot of people to be taken care of. And so, like, if you look at South Korea, as you were saying, they're one that has aged very, very fast. I think their average age is far, far older than, say, the US. And so it's an interesting thing there that they have compensated so significantly with automation and are still very competitive. Like, they're doing great work over there in general, in my opinion, or from what I know.
Yeah, I completely agree. And continuing on the South Korea use case, it's interesting. Their birth rates are below like 1. So it means they're like well below the replacement rate. And what's interesting is even as the population has aged there, the unemployment rate there is very low. It's been consistently below 5%. And you're totally right. So as the population gets older, we're saying like, who's gonna care for this aging population? And I think that's where robotics and automation can come in. You can have a humanoid robot that, if I'm imagining myself, kicking it in an elderly care facility one day, like I'd have my humanoid robot buddy that would help me with, various tasks. You can have things like, automated systems that dispense prescriptions, for example, that can improve the safety of, maybe you have somebody elderly that's accidentally taking too many or not taking them. So there's all kinds of things where you can both improve the elderly care experience. And as you mentioned, as a population, as more and more people are not working, and it means that of the existing workforce is not enough to sustain the whole economy. And that's where robotics, honestly, is going to be able to come in a big way.
Yep. That's why this is a big reason I'm so bullish on robotics for the near future. I think necessity is going to pull robotics to be bigger and bigger because of this kind of thing, this large demographic trend. But so you mentioned pill counting and things like that. Tell me about some of the things your cameras are being used for, like cool automation tasks. Obviously, they're used in quite a number of robots, but tell me about some of the tasks that your platforms enable.
Yeah, absolutely. I'll start by sharing an example, which is in the industrial equipment and agricultural space. And so we're helping a large industrial equipment manufacturer where the machines are used for things like agriculture and mining and stuff like that. We're helping them on a multi-year, it'll probably end up being like a decade-long journey of doing 3 key steps. The first step is we're making it so that the machines stop harming the human. And it's pretty shocking around the world. Machines kill millions of humans per year today. And we unfortunately tolerate it. Now, a lot of those obviously are like automobile accidents, for example, but there's a lot of industrial equipment as well. So step one is to make it so that there's human machine safety, and so that the machine's top priority at all times is to make sure that if there's a human around, that they're not going to harm it. And so what our cameras do is they make it so that the industrial equipment, it can see what's around them, and it can make sure that arms, limbs, humans are avoided and the equipment doesn't harm them. And then the second step with that company is that, and the industry in general, is to make it so that the equipment can operate remotely. And so a lot of these pieces of equipment they're pretty difficult to operate over a long time. They vibrate a lot. They're pretty hard on the operators. And so by being able to operate it remotely, it makes it so you can operate them more safely and more efficiently. And then the final frontier is to make it so the equipment can operate completely autonomously. And so that's where you can set it off on a task, and you maybe have some remote folks that can take over if needed, but they're mostly operating autonomously. And so I think you see that across different industries, but that's that's an example in the industrial equipment space that we're helping with.
I really like that. Yeah, I'm just thinking back to an interview with Polymath Robotics where they were talking about just driving massive amounts of, say, toxic chemicals or like molten metal or crazy things that you don't want to be exposed to. And the pay is high, but the cancer rates are high in the workers and this kind of thing. And so if you can make it so that we can automate or remotely operate some of these tasks, like that's huge wins.
Yeah, absolutely. And what's also interesting is the equipment in a lot of cases can be designed better and more performantly. And an example I'll use is with fighter pilots. We're used to kind of this, Top Gun fighter pilot. And what's interesting today is that, basically, AI operated fighter jets are able to outperform a human. And what's so interesting is you can design them so that they could, say, be moving at more than 10 Gs. It's something that a human couldn't handle, but the machine doesn't care. If the machine doesn't have a human, it can operate more performantly. And so I think in a lot of cases, this industrial equipment, you can reimagine the way it's operated because you don't need to have a space for the operator, and you can make it operate in a way that, you'd say, oh, maybe that's too high vibration or it's going somewhere that wouldn't be safe. And so it unlocks, new opportunities for efficiency as well.
Yeah, very true. And especially if we can automate stuff. I'm thinking of like electric sheep, having a bunch of little lawnmowers that go and mow because it's safer and it's easier to manage and everything else. And then they can't cause as much damage. And so if you do that kind of thing, then you don't have to have the big rider that requires a person to operate it. And they're big because there aren't many people for these roles, for this kind of thing. So yeah, I imagine the form factor changing quite a bit. And those jets that they'll go and turn incredibly quickly, and it would like turn a human into mush or something like that at those speeds. Those are just bonkers what you can do with AI or with a computer driving everything, or even being remotely operated, I suppose. How wild.
What a time to be alive. It's incredible.
Now, another thing that's interesting about what I think you guys are doing is you're also putting a lot of compute. So we've talked about all the sensors that you're enabling, but you've been also putting the compute with the sensors. So some of the platforms have like a powerful computer attached to them, correct? Would you tell me about those?
Yeah, that's right. And so that's really the other kind of second key durable product strategy that we have, which is that we enable essentially a computer that's right there on the edge, right, with all the sensors. And so what that means is that you're able to run applications and business logic right on the device, and it means that you're able to artificial intelligence models. You're able actually to run the inference where it's actually operating. You're able to also run that on the edge on the device. And so our thesis is that customers are always going to want to have more of that. They're always going to want to have more on the edge because they are able to solve one use case and they're like, this is exciting, we want to solve more. And so what Luxonis equipment does is it provides the opportunity to eliminate an external dependency like needing to have cloud. And so customers that are maybe spending a lot of money today on cloud compute, cloud inference, they're able to take that workload and they're able to take it to the edge. And they're able to, they own the hardware and they're able to have a massive, savings over time when they're going to operate in their production environments. And so for our products, we actually had a new generation of hardware. It's our Series 4 of hardware. It's this is an example of one right here that I'm holding up. And so this little device has more processing power than the laptop that I'm on here, and it has 48 TOPS for AI inference. And so what that means is that they're able to run several vision models in parallel. So you could have a model that could do one thing, another thing, another thing. You're able to run all that simultaneously, which is incredible.
Well, you said TOPS. Is that like terabyte of floating point operations? Or
yeah, it's trillions of operations per second.
Wow. Yeah, that's wild. Yeah, so you can run lots of models all at once on this.
Yeah, exactly.
That's amazing. And so then with this, you're empowering on the edge. So you're making it so that you can have really good compute demands, or really, really sophisticated compute occurring at the edge. And this helps you get away from the cloud. The thing that I'm imagining with this is it's like you have your like sensor stack that is one of your devices, and then you just have it connecting to a lot of things. And by doing that, it's like this little almost parasite that can be put on to any other kind of equipment. And then it can do a lot of the automation really, really well. And it's all just like you basically have the one node and then you have little wires running everywhere else, like this kind of thing as a potential workflow or way of having these devices. Is that kind of the vision? Having this little thing sit somewhere and then automate something bigger? Or how do you imagine it?
What you described is definitely one of the main two use cases. And so the use cases really bifurcate between one is where you have kind of a standalone automation device. And that would be where you maybe have this camera that would be up and it'd be connected to maybe the infrastructure that you have locally. And it would be operating everything. And it could be, say, like observing something in the world. So this could be somewhere and it could be doing, say, license plate recognition. And it could be running an application that's, detecting a vehicle, detecting a license plate, and then it's sending that license plate data somewhere. What you described is the second main use case, which is where our devices are integrated into a larger assembly, and that's really the kind of the canonical example is things like autonomous mobile robots, and so that's where you have one of our cameras is there, and it's like you said, it's kind of a node that's a peripheral device that's capturing all the sensor data. It's helping offload a little bit of the compute and some of the the AI inference. And then it's combined to a larger assembly. The area that is one area of kind of robotics that's pretty exciting is humanoids, for example. And so we work with several humanoid customers, and these humanoids they need to be able to kind of navigate the world. So they frequently have one of our cameras in the front, and then one of our cameras in the back. And then that's then combined to, of course, you have a lot of other sensors that's on the humanoid, and you have a lot more compute that's on it as well. And so it's kind of one sensor in a broad, kind of a broad ecosystem to do something which is very complicated, which is, having try to make a robot that can navigate the world in the way a human can.
Mm-hmm. Yeah, that's very exciting. So when you have multiple ones, the one in the front and the one in the back, or say you're automating a tractor or something like this that requires several around so that you can see everywhere it's going, or see all sides of it while it's operating, how do you connect multiple devices, and does this change if those devices have compute, or would you imagine having like one with compute or a bigger computer somewhere else, and then all these other ones as peripherals to it, or how does connecting lots of them work?
That's a great question. So our devices have, which I'll hold up here, they have, in this case with Series 4, they have USB-C, which is like what you'd use to power your iPhone for connectivity. And then they also have these ports here, and this port here is an Ethernet port, so you can use Ethernet for power and connectivity. And then there's another port here, which is called like an M8 connector. And what that is a connector that makes it so you can actually daisy chain the devices together. And so by daisy chaining them together, you can have an array of them that are pointed at different things. And then that data can all be captured and kind of fused together into one broad picture, one broad scene, to be able to, navigate whatever you're working on. So that is one example. There are also cases where our devices are, and it's more like kind of this device here, it's really used as a peripheral device, and multiple of them would be connected into some type of a central compute box that would be processing all of the data and making sense of it.
Mm-hmm. So tell me about the AI models that you have and how those play in. So especially for the ones with compute, but it sounds like you have the option to do a lot of fairly sophisticated observation of whatever the sensor is seeing. And I'd love to hear how you do that and how you expose that to the user.
Yeah, absolutely. So we have a team of about 20 artificial intelligence engineers. And we also have some folks that work on creating synthetic data. And so I'll kind of start with, if you're a business customer and you have no data and you're like, how do I go about creating an AI model? So what you can do is you can grab some maybe publicly available data that's out there. And so, for example, use like license plate recognition technology. So you can maybe buy a publicly available data set that has some license plates, for example. And then what you're wanting to do to develop a model is you maybe start to want to add your own proprietary data. And this is data that's unique to your own operation that you're wanting to basically take existing data out there and you're wanting to customize it for exactly your purpose. And so there's two ways that you go about doing that. The first is you create synthetic data, which we help do for our customers. And that's where you create these scenes. We actually use a tool called Unity, and it's the same thing that's used for creating video games. So you basically imagine is you basically create a bunch of scenes that would be as good as a video game. And those scenes are good enough quality that they can be used to help train the AI model along with the publicly available data that you have. That gets you a proof of concept. That gets you something that says, okay, we have a model, we can go out and test it. Maybe it works 80, 90%. And 80, 90% is nowhere near good enough. If you want to have something that's out there that's, adapting to the real world, handling edge cases, the world's always changing, you need to capture actual real world data that's, from the actual situation that you're trying to navigate. So that's where our cameras come in. So what our cameras do is they capture new image data, and that image data then can be used to be labeled. And then with that labeled data, then you can then retrain the model. And what that does is it creates an ecosystem where you can iteratively improve your model and start to get something that maybe works 99% of the time or 99+% of the time. And then over time, it becomes more and more proprietary, custom built for your exact purpose, because you're capturing and feeding it in data that's from your actual, business use case.
Yeah, very interesting. It's cool to hear that you guys are using Unity for generating quite a bit of data. For labeling data, once you're getting your own data, do you have any workflows for that? Like, do you make it easy for people to do it, or do they just have to figure out how to grab it within the relevant times and then label it? Or I imagine this is a vertical you'll start to get to, but are you working on it yet, or how is labeling?
Yeah, we are. So it's a combination of things. The first is that we have an in-house labeling team. They're actually located in Tunisia. So in Tunisia and Tunis, we have one of our machine learning engineers, and we have a small group of folks that help to do the manual data labeling that's needed. So what we do for those type of opportunities with our clients is we put together some training information over exactly what we're trying to label in each image. And then what we do is they go out and they're labeling, thousands, tens of thousands of images. And then we have mechanisms for being able to, manually and with technology audit, to make sure that we're labeling things right. If you don't label things correctly, then you don't know the truth. And if you don't know the truth, then you can't create something that's going to be useful. So that's why labeling, of course, is so critical. And then the other part that we use is that when synthetic data is created, and also this technology is in some cases used for real world data, you can auto label it. And so that's where you kind of tell a computer, hey, this is the type of thing that I'm trying to label. When it's in Unity, it's very clear, because in Unity, of course, when the scene's built, you've labeled everything and it can capture it. And then with real world data, you in some cases it can work really well. You can say, okay, here's how you want to auto label it. And in some cases, you have to do something that's pretty manual. So you put that all together, and it makes it so that for customers that need tens of thousands, in some cases hundreds of thousands or millions of images, proprietary images that were labeled for them, that's how we go about helping them do that.
Cool. I did not realize. So from what it sounds like to me, you guys are a lot more service based than I had realized for this. Like helping with data generation and simulation, and then also helping with labeling with your labeling team. Is that a large part of your revenue, or is it a growing part? Because that seems very interesting, because it's like almost you could sell the devices at cost, say, and then have teams that help with services that customers will need, like data generation and labeling for this kind of thing. Is it a large part of your business model? Is it growing? How do you think about it?
So it is a significant portion of our business model. And the way that we think about it is that we're trying to get our clients to get to where they, have a solution that they can deploy at scale. And when we see that there's gaps in the market, we work to fill them, because, we want to help our clients get there as fast as possible. And it creates this nice virtuous cycle. And what that cycle is that clients buy hardware, then they're able to, use our services to be able to get it so that hardware can do something useful for them on the software side. And, they pay us for that. And then in turn, when that software works well, then they go and they buy more hardware. And so that's like a nice, very complementary part of our revenue model. The majority of our revenue today is from hardware sales, I'd say approximately 80%, something along those lines. But we do also have a growing, software development portion as well. And so in some cases, those are software tools where the client's able to use the tools on their own. And then in other cases, they're using those tools, but we have,
teams.
Yeah, we kind of think of it as like the enterprise tile of that kind of software tool, where we have teams that are helping them kind of get to their, aha moment where they can scale up.
Do you imagine, so in, say, you've been around for 6 years, do you imagine in 4 years from now that this is like 80% of your revenue? Or do you think it'll always stay a kind of small thing? Or what would you imagine?
So I'll first say we don't know for sure.
Is it a relatively new thing?
No, it's not a relatively new thing, and it's something that we talk a lot about. So I'll first say that we're flexible on whatever is going to be the best path for us as an organization, and we're exploring different options of what that could look like. One thing that's out there, like you already mentioned, is you could potentially sell the hardware at a lower price or at no price, and then you have it kind of bundled as a, call it a platform as a service or something along those lines. So that's something that we think would be a model that could be a really enticing, growth opportunity for us for certain clients where that fits into their operation. And what it does is it moves kind of the the way that they can scale up with Luxonis, it moves it from being, you know, a CapEx to an OpEx. And that can really work well for certain business models. So
I would think so too.
Yeah, so we are open to exploring that more, you know, as we grow. I will say that we do believe that the software kind of subscription portion is going to be a major contributor to our revenue long term. We don't know what the exact mix is, you know, when we're, you know, 10x our scale right now. Is it half? Is it 20%? You know, we don't know yet.
It's hard to see. Yeah.
But you know, we ultimately believe that, you know, our value proposition is that, you know, we have great hardware that you know helps make great, that goes along with great software that can do something useful. And so we're kind of really, we're trying to do everything we can to just stay customer obsessed. And so like the reason why we've done the things that I mentioned before on like data labeling and some of these services is we know it's a pain point for our customers. We know we can solve it. And so we kind of work backwards from that and tackled it. So we'll kind of remain kind of with our customers, kind of, you know, hopefully get guiding the way for us to be able to navigate what the exact mix of that is.
Yeah, I think that's really clever. And I think that seems like a very good model to me. And yeah, I guess the market will pull you in the correct direction, so you allocate accordingly. But it seems like a nice thing, because I'm thinking of, say, startups. A thing that's hard with startups is getting people that are very sophisticated, like super experts in some narrow thing that your startup needs. And so a lot of times it's easier to just hire out those specific roles. And so it's interesting. It's like you guys already have the expertise. You're putting the pipelines in place that make it so you are very efficient at data labeling. You have your team allocated. You already know how all your software works, so that it's very easy for you to get the data. And then they don't have to, like, you can help them bootstrap and go from 80% working to 99% or 99.9 and a few other nines working. And then that allows them to deploy more, and then they just buy more. And the in-house part of training, or the part of training their model, has just been completely outsourced to you guys, which would be really cool. So I don't know. I'm just thinking that's a really cool model, and you could take equity in some of these companies if they're very early, which would be a fun thing.
Yeah, you're exactly right. I think these organizations are looking at a classical trade-off of like, do we make versus buy? And when they're looking at that, we like to think that usually when they see, you know, the relatively, you know, competitive, economic price of our cameras and what the platform can provide, that they say, yeah, this is a no-brainer. There's other things that maybe we want to try to make ourselves, but in this case, we should just buy these devices. And the other thing is we really want to control our own destiny with our clients. And so when in a world where we say, oh, we've solved this area here over on this side, but we have this other pain point that's blocking our clients from getting further along. And so by being able to kind of control those aspects, it makes it so that, you know, we have the capability to get the client all the way to the finish line. And that at the current stage of where, you know, the intersection of robotics and artificial intelligence is, I think that's really important to us. You have a lot of customers today that are really, you know, they're really pursuing investments in this area and exploring a lot of stuff. And what it means is you have a lot of pilots and, you know, is this possible? Is that possible? And we're really obsessed with trying to be able to have a really high conversion rate from those pilots to actually, you know, going at scale. Of course, some of that is selfish. Like we want to be able to grow our revenue in a big way, but it's also like about what's rewarding. It's not rewarding to work on pilots all the time. What's really rewarding is you actually get to see that innovation used intensely at scale. And so for our engineers, the 8 engineers I mentioned, the most exciting part is when you actually get to go, oh my gosh, like look at this that's being used out there in the world. So that's you know, we're really kind of obsessed with that part of things.
Totally. Yeah. For so like, I mean, I've been at Open Robotics, and then we were acquired by Intrinsic. But so Open Robotics does ROS, and a thing that was really exciting is when iRobot announced that they were using ROS 2. And so now ROS 2 is on a whole bunch of robots all around. And that was just like the biggest win for our team for this kind of thing. So I can imagine it's like, yeah, when you see people using what you're making really productively, that's super, super cool and energizing.
Yeah, absolutely. And I'll say that, the world has changed in such an interesting way on our journey. Just to kind of add in here, I kind of think of it as, 2022 is kind of this like before Christ, after Christ moment for artificial intelligence. And before 2020, call it 2023, as things kind of really scaled up there, organizations were not asking themselves, how can we use artificial intelligence in robotics? They weren't doing that from the top very often. It was coming very bottoms up. Engineers were saying, begging their leadership, hey, there's so much that's possible here. Let's lean in and invest. And now that we're in this kind of like after Christ moment, excuse the the religious analogy, is that organizations are now doing it from a very top-down perspective, and they're asking themselves, like their leadership teams or executives, their board of directors are saying, are we investing enough here? Are we moving fast enough? How can we do more? How can we drive things? And so that's been really cool in the conversation, that a lot more of our discussions today, where, circa 2022, it was like 100% was just engineers. That was all we talked to when we were doing sales. It's now become honestly like a 50-50 split, where you have a lot of people that are, more on the leadership down side of things. Now the bottoms up is still excited about it too. They're driving it too. So it's been interesting to see the way the world's changed there, and that really became solidified in 2024, and that momentum is really continuing into 2025, which is really exciting to see.
How do you think it will? So, okay, 2022, 2023, 2024, 2025. How do you think it'll go for the rest of, like, how do you project that trend will continue, or like, where do you think it'll go? So like 2026, 2027, like, where do you see it going? Maybe 2030 or 2030, all these things, like, what do you bet?
Yeah, it's a great question. We think about this a lot. I think that the example that I think is most tangible to sort of think about is probably in humanoid robotics. And with humanoids, if you think about, what's the total addressable market for it? And the reality is, like in a place like the United States, I think I saw a research study that said, the addressable market should be like 400 million of them. And so I think humanoids, what they would enable is that if you have a humanoid that can do, pretty much anything that a human can do, which is, starting to seem feasible, call it by the end of this decade, then you really get to this kind of moment that's sort of similar to like the computer revolution of all of a sudden everybody had a laptop on every desk. I think they said Microsoft was founded with the idea that, Bill Gates and Paul Allen had, is just a laptop on every desk. That was it. And that became a reality, right? And so I think with humanoids, you have this possibility that it's a humanoid in every home and a humanoid in every workplace. And so I think that that's where you can kind of see things projecting out to, is I think embodied AI, and where you have these kind of this uber multimodal model that can kind of just have this whole worldview, this kind of world model of it can do, behavior and vision and, sound and, voice and, all of the above. And I think that's where the intersection of all of this technology is kind of converging in an exciting way.
Yeah, it is really exciting. It's very interesting to me. So like being in robotics over the last like 15 years or so, and it's just wild how much things have changed. It's like what I learned in school has like, it's just not the way we do things anymore for a lot of things, which is just absolutely crazy. So it's moving fast and it's changing, and better hardware like you guys are making makes it much easier to do things. Like the barrier to entry is decreasing, the ability to do stuff is increasing. It's just wild.
Yeah, it's really exciting. 20 years ago, during my undergrad, I studied mechanical engineering, and my kind of focus, the kind of all the extra classes I could take was in mechatronics and robotics. And so we built robots that played dodgeball against each other. We built robots that played capture the flag. We did things like, the inverted pendulum and all this cool stuff. And, it's funny, thinking back to that, 20 years ago, of where we come to today, and, getting to see, for example, like Waymo cars scale up with autonomous driving, and thinking back to, this autonomous robot that you pointed the sensor at the table and it could sense, black tape, and that was how it could go. And it kind of back then, the idea that, you could translate this all the way up to, say, having a totally autonomous, 5,000-pound car barreling down the road at 70 miles an hour. It's really exciting to see the progress for sure.
Mm-hmm. One thing that was pretty exciting to me with ChatGPT was their vision capabilities. So you could put a picture in and it will have fairly sophisticated scene understanding, at least by what it's able to write for this kind of thing. So I really like that kind of thing. You guys, being that you have cameras and compute, I imagine are well placed to do that kind of thing and have it locally because you have powerful compute. Tell me about some of these newer AI techniques, if you're leveraging that all or enabling them at all.
This is an area that we've been doing a lot of exploratory research, talking to some different folks and, evaluating it internally. Some of the use cases that we think are pretty interesting is that if you have you have a video, a bunch of sensor data that's streaming off of a device that, with an API and a simple, natural language interface, you could maybe ask it a question. You could say, describe what you're seeing right now. You could potentially say, hey, can you send me a notification every time you see something like this? You see somebody fall down. Now, right now, if you wanted to create, say, a system that detected when somebody fell, maybe you'd have to create a model or something like that. But with these types of tools, you make it so that maybe you just say, hey, just let me know the last time in this video stream that you saw somebody fall down. And so it makes it so that you could grab real-time data, but it also makes it so you could search the data too. So you could say, hey, I've got 24 hours of video saved. Maybe you're a construction site and you're the safety manager. And you say, can you point me to the points in the last 24 hours when we saw something that was dangerous that was happening, something where somebody wasn't wearing their safety equipment, something like that. And so I think that that's really interesting for us. We do believe with the cloud application layer that we have, that we can enable that type of technology pretty well. And we're kind of exploring the ways that can be, I guess we'll call it a really meaningful step in the journey to really democratizing, computer vision. Making it so that something like that would be pretty difficult for an engineer to do classically.
Definitely.
Where it could be something where, anybody that's even not a coder would be able to, grab some cameras and just start doing some natural language prompts and, find out what's going on and set things up. So it's definitely exciting, something we're exploring. There's some really promising new companies and startups that are tackling this. I know a lot of latest crop of startups over the last couple of years have been founded around, working on this type of use case.
Cool. Yeah, what a nice thing that is. I mean, I haven't thought of it, but the ability to search data really quick, search video really quickly would be incredible. If you could say, hey, take me to the moment this is happening. And it goes, oh, yeah, here you go. That would be awesome. I wonder, one of the things that I thought was really cool, and I built a little prototype of this for some side projects, was you take an image and then you have it select from a few options. So it's kind of image does all of its thinking and then it selects one of a few options, which might be drive a robot forward, turn around, pick up an object, whatever. I feel like this kind of thing is very useful too, just for prototyping stuff. Or even, they're real simple applications that people could have, or even more sophisticated ones that you could do with this kind of framework.
Yeah, absolutely. I know that, one really cool video that's out there is, say, the figure AI humanoid, and, it's looking at the table and it says, what do you think you should do next? And there's a dirty dish, and it's I should probably put the dirty dish and put it in the dishwasher. And so I think that's really interesting when you think about kind of these behavior models for robotics companies that are working on kind of prototyping what's possible. And I think that's where that real-time understanding of video can be really useful, so that you'd be able to practice different prompts based on the scene that you're seeing. what are the 3 next steps that you could see that you'd want to take? And, a way that it can really start to learn. And what it really tackles is that, robotics had been used for decades in really big scaled environments, but they're very controlled, right? So this could be, say like a automobile manufacturing plant. It's doing the same task a million times over and over. It doesn't even need vision, right? It's doing it on a precision basis. You're taking this item, you're putting it here, things like that. And when you go into these unstructured environments, that's where it's, of course, really challenging because the scene's always changing. It's navigating something that's never happened before. It's a scene that's never existed in all of history because it's completely unique. and that's where I think that like I said, the real time understanding could be really interesting on kind of prompting those next steps and what have you.
Mm-hmm. Do you, I don't really know well, but maybe because you guys have been looking into it, do you know much about how it is to do these scene understanding tasks with video for this? Like, I'm imagining trying to use transformers or something, some AI technology on it where it's trying to find features that are relevant and look at them over time. It sounds really hard to me, but it's also kind of magic. Do you have any like thoughts on how feasible it is? Because right now, like OpenAI's Chat GPT, I think just does images. Maybe it does videos, but what's kind of the state of the art in language models with video models or something, video large models or something?
I use ChatGPT a lot. It's really cool. I go on these hikes. Yesterday I was on a hike and I saw this footprint and I didn't, animal print, I didn't recognize it. I just took a quick picture and I said, hey, ChatGPT, what animal do you think this is? And it looked at it and it said, described it. And it said, we think this is a deer and this is why. And I'm like, oh, that's it's so cool. And it does do video as well.
It does? Oh, wow.
What we've learned is that there's different, or I believe it does video. What we've learned is that there's different techniques that the different companies are using to try to be able to do it. The real question mark for us is whether we can now or in the future have hardware or it could run on the edge. And I think that what that could entail is that, right now the artificial intelligence, purpose-built hardware that we have is primarily around doing inference. So you have a model and it's just kind of inferring and operating the scene that it's seeing. But what we potentially could do is we could have look to also enable like Gen AI on the edge, and so that's where it's generating something. And there's because it stands today, we're probably, if we're enabling something like this, it's probably going to be enabled with, say, something that's done on the cloud. So that's really the kind of a question that we have as we try to navigate this. Is this something where we want to do that? Now, when I did the example I shared with ChatGPT, that took, I think, 30 or 45 seconds because, that prompt is run in the cloud where it's processed somewhere. So kind of the question is like, whether it's we're talking about like my latest smartphone or we're talking about like our latest devices, is it possible to be able to do that on the edge? Because that's where our value proposition comes up, because then you could have it be lower latency. And that's where latency really matters, right? Is what's a way that you could do that in like a very real time basis versus something that maybe would have more of a lag.
Yeah, I see. So focusing on the edge, it's not clear if it's in scope or when it will be in scope, because you never know. I mean, some of the models seem to be getting lighter and lighter, but you never know if it'll be as sophisticated or if it'll be able to do vision related things. I don't know how large any of these vision models are.
Yeah, that's exactly right. And so for us, it's all about like, what do we do best? And for us, it makes sense to enable this sort of technology if we can ultimately, maybe not initially, but we know that we have a path where we can enable that on the edge. Then that's where it becomes something that becomes really compelling for us. And so that's the main lens that we're kind of evaluating it through. And then putting that aside, like the holy cow, wow, neat factor is so high that testing it out is well worth it.
Yeah, hell yeah. So one thing that's interesting to me, especially with thinking about you guys having more of a like service or where you're working with a lot of customers, um, do you ever like, I imagine you come across a lot of like really good use cases that you're very well suited for. It's an interesting thing because I imagine if I was in a similar position to you, I would be distracted by all the cool applications that are coming up. And I would want to go run a startup or have something related to each like of the like really promising problems that you come across. How do you think about this? And I know you're working with the customers, but I don't know. Just tell me about all the cool domains that you're coming in touch with and how you think about it, I suppose.
So we have a lot of very spirited debates on this topic, as you can imagine. And what it really,
like, yeah, we have the expertise. You have the technology, you have the manufacturing. Sometimes it's like just if you were to run with it, you're in the best position to capitalize on it, is what I would imagine.
yeah, that's right. And so what it boils down to is, what's our focus? What are the areas where we think that we have, an unfair advantage to be able to pursue them and scale up with our clients? And the industries that we work in today, I'll kind of put them in a few different buckets. So one of them is, kind of transportation, logistics, and warehousing. Another one is industrial equipment and agriculture, like I mentioned earlier. And then another area is like retail and quick serve restaurants. And then kind of some final buckets is call it, construction and manufacturing. And at any time in our journey, we probably could just have already picked one of those and just said, we're going to ignore all of the rest. And we're just going to narrowly focus all in on this. And I will say that like the coolest part of the job is getting to learn across all of these different cases. So like selfishly, I'd be a little sad if we went all in one area, but very agnostic to it. And really it's about like, if we think that our innovations can be used most intensely in one area, then we want to focus there. So we do have some spots where we are trying to kind of lean more into because we're seeing that our investments there are paying off in the way that we'd want. And as we look ahead, we're really trying to make it so that, we probably have, I'd say probably no more than 3 kind of concentrated bets in the areas that we think that we can, continue to get the most traction in. So a lot of the first 6 years of our journey has kind of been figuring out these different industries, figuring out how they operate, figuring out how our technology can help. And then as you look ahead to, knock on wood, hopefully call it our next 6 years, it's really probably being a bit more narrowed, saying, here's like I said, probably 3, maybe like 4 or 5 max, but probably just a few industries where we're like, yeah, this is where we want to go all in and focus the technology the most.
What are those? What are those areas for you? The 3 areas you want to make bets on?
Well, I shared with you kind of the main industries that we're in today. And I think, without a doubt, it'd be kind of one of those for sure. Or some of those for sure. So I'd say any one of them, to be honest, like we could go deep on it. I could explain why I think it could be like a very bullish case of why we could go after it. And I guess I'll answer it today is saying that like we don't have 3 that we've picked yet. We're starting to have really strong hypotheses on why we think some might be better than the others, but don't have enough data and conviction today to say, oh, this is this is what we know for sure and want to go all in on.
Yeah, it's an interesting thing because you guys are well positioned. I just like the thing that I would think is it's like a lot of companies, they'll build something general on their way to finding something very specific. And then they go hard at the really specific application where you have lots of growth potential. And then that growth gets to fund the more general again, which is quite cool. So I don't know. I would love to hear you make a bullish case on maybe 1 or 2 of the different areas that are somewhat like agriculture or one of the other ones that you were saying, maybe manufacturing or I don't know. I'd love
Yeah.
to hear the case on it.
Yeah, absolutely. Well, I'll say that the areas that we have our biggest customers, where we're having the biggest revenue gains, one of them is in security, actually. And
Oh, I'm not surprised by that, actually. Okay.
yeah, it's an interesting space I can talk a little bit more about.
Because also, like home security systems, I did a deep dive maybe a year or two ago, and they really suck. And there's a lot of bad data privacy concerns with most of the leading ones, it seems. And so I have half been wanting to just build my own for this kind of thing. Like, how cool would it be? You just have a camera pointing to something and it says, did I leave the garage door open? Did I leave the stove on? And you have it answer this kind of thing. But okay, I'd love to hear more about security for
Yeah,
this one. It seems great to me.
Yeah, it's exciting for sure. So I'll say that I'll talk about security in a second. The another area where we're getting a lot of traction is just kind of related to automobiles. And so, related to automobiles, we've done some stuff with like AI dash cams. We've done some stuff on, calibrating some of the vehicle systems themselves. And then some of them on, monitoring and observing the vehicles, like license plate recognition. So that's another huge area for sure. And then I would say that, I do think the agricultural and industrial equipment space has also been really promising for us. The area that we have not had as much traction, but we actually are pretty bullish on, is like the quick serve restaurant retail case. And to go back to the beginning, so with security, we've traditionally thought that security was an industry to potentially avoid, in the sense that we're like, okay, what can we do that's special here that say home security systems or legacy systems can't provide? And yeah, we've found some really exciting opportunities where we're helping in the kind of security screening that would happen at things like elementary schools, warehouses, stadiums, things like that. So this is really high volume, high throughput security where basically magnetic technology is then fused with vision technology to make it so that if a stream of people are walking in somewhere, you can the weapon can be detected and tagged to an individual, and that person can be grabbed. These systems are kind of necessary if you want to get like 100,000 people into somewhere really quickly, or you want to be able to get, say, a couple thousand people in school on time every day, and you want to screen them. You can't use like a traditional metal detector. It's just too slow. So that's where like these kind of higher throughput, in some cases more performant, because you can be kind of sensitive to certain types of weapons. That's where we've kind of seen with security.
Interesting. Okay. Very cool case for this kind of thing, but not compelling enough to make you want to not jump ship, but like pivot a little bit in this direction. I guess, because then it's finding, like you guys have been on the specific problem of making your own hardware work really well and then adding compute into it. So those have all been difficult lifts, I imagine, for the team. And so this would be like acquiring domain expertise, finding a good problem, finding a good market, and then everything else on top of that. So makes sense, but still cool. I wonder if eventually you guys get bored ever with where you're at. Go pivot and make startups around it or something for specific domains.
Yeah, we've seriously thought about having kind of creating sister companies that would tackle these specific cases. What's interesting is you get really industry specific is, it can kind of become a whole company on its own.
It is, yeah.
And so an example area could be, say, the military. And so in the United States, of course, there's been a lot of investment, kind of actually venture capital investment, which hasn't historically happened, that's gone into, new generations of technology across the military. And it's of course pretty specialized, that technology. It requires a lot of like domain expertise. And so, these things are interesting for sure. So, I mean, who knows? We'll see how it plays out. It's gonna be fun to watch whatever ends up happening that we do for sure.
Yeah, you guys are in such an exciting spot with all of this. What do you think? So, I mean, we've talked a little bit about what the future is. What do you think your future is, like Luxonis's future is, when you think of the next, like, 3 to 5 years? Where do you hope you guys grow?
So we are, 6 years deep into this, like I said, but fortunately we have a team of folks that are, young, hungry, excited for the future. So, one of our core values is kind of the tagline, creating the future. And I think there's this great quote I read in some book about the history of semiconductors that, said that the best way to predict the future is to create it. And so,
Definitely.
We definitely kind of believe in that. We're very heads down and in just this intense building phase. And so, we think as we scale up, we're excited to be, more than anything, like I said, having an increasing kind of, plethora of these use cases that have gone to really, really big scale. And I think what's so cool, for example, is like we recently were at CES, the trade show in Las Vegas, and there were dozens of companies and booths that were using our cameras for various things. And in a lot of them, there are folks who we never even heard of before. And, that type of thing is really rewarding. So I think as a company, we do aspire to become the de facto provider of artificial intelligence, 3D camera devices. And we've really positioned ourselves to be the leading independent American provider of that, which we're really, really proud of. And so, we see the future as us just wanting to build on that success, become, like I said, the go-to spot where folks can, from start to finish, be able to, tackle these, computer vision problems. And none of us is in a hurry to get to, whatever the end of this journey is. We're having a lot of fun, and we show up just really excited every day for it.
Yeah. I mean, the fact that you guys have grown very organically, like the Kickstarter campaigns in the beginning, and then friends and family funding and bootstrapping to where you are with a few rounds of like angel investment. It sounds like a fun journey. Like, I don't know, better than like we took a bunch of investment. We're under huge pressure to scale as quickly as possible. And the runway is rapidly burning up, this kind of thing. Like it just, I don't know. And then you're seeing all of these really cool use cases. You're getting a lot of feedback from the community where they're enjoying your sensors. I can imagine it's been a very fun ride so far. And I expect it will probably keep being a really great one too. I think you're well positioned.
Yeah, thank you. Yeah, I mean, we're, in some cases we haven't done something that's, necessarily traditional in how the, we're able to scale the company. But yeah, we're very fortunate that that's worked well the way that we have. And and yeah, I mean, it's a cool spot to be. I mean, I will say that the startup journey is not for the faint of heart. It has, I mean, it is literally like a roller coaster. It's frequently a Monday, and it's like, gosh, this is never going to work. What are we doing? This is not working out. And then, Tuesday comes around and we're like, oh my gosh, this thing's going to the moon. This is so exciting. Oh my gosh, like grab on tight. This is a rocket ship. So it's, it's the ups and downs are intense, but I personally wouldn't have it any other way for sure.
Oh yeah. Do you have any specific stories around the roller coaster? Like, I'd love to hear anything for that.
Oh gosh. Whew. Yeah, there's so many for sure. I mean, I'd say like this week is it's not like maybe the best examples, but I'll share it like it's just this week because it gives you the top of mind for me. Because hopefully I've already forgot what the last ones are, because if I kept remembering them, it'd be too dramatic. So we actually won a very large order this week, and so it was let's see, it was a few $1 million order that we won, and we're delivering all the units this year, and it should scale up a lot from here. And it's with a global Fortune 100 company. Can't say the name, but something we're really proud of and been working on for a long time. So that's so like exciting. Super excited. That's the big win for the week. The big loss is we had an, I won't say which government entity, but we had an unexpected tax bill. And it's funny, we operate around the world. We ship into 112 countries. We sell product in all 50 states. We have employees located in several states throughout the United States. We have employees and contractors in a dozen countries around the world. And as a startup, there are different government groups that we didn't realize that we needed to do this or that with. So we had an unexpected one this week where we have this tax bill, and it's fine. We'll pay the tax bill. It's not the end of the world, but it was unexpected for us. And of course, when you're a startup where you're not yet profitable and you're not yet positive cash flow, you're wanting to be able to reinvest every single dollar that you possibly can into hiring more people. So it's always disappointing when you go, oh shoot, we have to pay this tax over here that we didn't realize we had to, so we can't hire somebody new. So that was kind of the low point of the week. But luckily, the high point overwhelmed the low point for sure.
Oh yeah. Overall, the week was a win.
Yeah, exactly. And yeah, like I'll shed a tear, pour one out for the extra employee we'd like to have hired, and just hope that whatever government entity we have to give that money to, that they are going to spend it better than us, I guess.
What a thing. Yeah, taxes. So I'd like to just go a little bit more, like, I don't know, kind of random questions for different things now. What are your thoughts on vision, like cameras versus LiDAR?
Ultimately,
and kind of which application both are good for?
Yeah, so ultimately, we're actually agnostic to either technology. We are not trying to make a bet that says like it's all vision all the way or all LiDAR all the way. Oh yeah,
totally.
And so we're more, as I shared with you, we do have our first, LiDAR-based camera, which is a time-of-flight solution. And, of course, also our devices have a lot of cameras on top of other sensors. We understand the arguments for both cases. We talk internally about the example being like Tesla, who's gone all in with vision. And their thesis is, well, if a human can drive with vision, then, why can't a computer drive with vision? Whereas you have others, like, say, Waymo, that's gone, said, hey, we want every sensor we can get, and that's going to include LiDAR. What we see with our customers is that there's some cases where a LiDAR-based solution is better. And, we go, great, okay, we can support that. And then we see some where kind of vision can be better. I do think what'll be really interesting is that the economies of scale with cameras have made it so that you have really high performant, really low cost cameras. And like you mentioned, there's like, say, 1,000 megapixel camera out there. That's not the type of thing that's needed for most commercial use cases. Conversely, with LiDAR, the prices have stayed pretty high, but you do see that coming down really dramatically. So I think over the next 5 years, that's going to be the biggest change. And I think that's going to change the dynamics on, this LiDAR versus vision thing. And I wouldn't be surprised if, once the cost comes down low enough that, say companies people like Tesla would end up adding LiDAR anyway when, they can get it at a low enough cost.
Interesting. Yeah, I wonder if, so say like Waymo deploys massively, then that'll help LiDAR get huge economies of scale, or some other companies say. And then that might drive down the cost tremendously.
Yeah, we're seeing
that would be really cool.
Yeah, we're seeing some new market entrants that are, haven't scaled up yet, but are saying that they have, new technology, new techniques that make it so that they can do it a lot cheaper than the items that are out there. So I think that space is going to be very deflationary, and deflationary even for the normal scales that electronics have, which electronics, of course, has been a very deflationary space.
Definitely. Let's see. So another random segue. How you mentioned at the beginning 2022 and like all the chip craziness. Tell me, in the time of Luxonis into current day, and then also I'd love to hear your prediction of how it will be. How has procurement of the chips and different electrical components you need been over time?
I'd like to say it's gotten easy. It hasn't. There's still times where in a bill of materials that we have for one of our devices, which is, excuse me, depending on the device, maybe 50 to 150 items, there's still sometimes items that trip us up. So every time when we're looking at our production plans over the next upcoming period, we're still having to identify high risk items, and we're needing to, purchase ahead on them. And then we do have some components that have painfully long lead times. So one of our components for Series 4 of hardware, it has a 7-month lead time. Oof. And when you think of a 7-month lead time, once we have all the components, it takes, call it about 8 weeks to, manufacture and assemble them and get them ready to ship to customers. So that means is that we're sitting here today and we have to predict what's our demand going to be like for this device in 9 months. And, that is not
hard
easy to do.
Yeah.
You have to, just follow your instincts and hope and pray that it's going to work out. So yeah, it continues to be pretty challenging. And then as we look ahead, I think what's interesting, coming, for example, most recently at CES, Consumer Electronics Show in Las Vegas, where you have all of the different chip manufacturers that are showing off this latest and greatest hardware. You have a lot of them that are kind of more floating ideas, like, hey, here's a chip that could do this, or here's a chip that could do that. And you don't know yet, like, what are the ones that they're actually going to be supporting at scale. So I think as you look ahead, it's going to be really interesting to see how the pace of AI hardware progresses, and to see, what are some of these new market entrants that are going to kind of disrupt things outside of like kind of the legacy big chip providers. And what are the, is it going to continue to be this like dizzying array of different potential options, or is it going to get like a bit more narrow in terms of what's available? So that'll be, I think, as we look ahead, will be interesting to see, as you have just a lot of players working a lot of different stuff, and just so much. I mean, things are moving so fast there. You honestly can't keep up. Every few weeks there's some crazy new announcement on some new piece of AI hardware.
Yeah, for sure. Very interesting. You mentioned high risk items. Is there any like theme or pattern around the items that are typically high risk, in your opinion or in your experience?
It sometimes seems random. So a component that tripped us up recently was an LED, which is a light emitting diode. And it was to us, when we picked the design, it was an available component. It seemed pretty standard. It turned out that there's basically only one manufacturer that was making it. They had an issue, and, boom, it caused I think it was like a 4-week delay or something like that. So sometimes it's really random. It's our job to try to not let those type of situations come out of nowhere on us. I will say that the things that were tripping folks up, back in 21 and 22, things like memory and storage, that area has gotten stable, where there's a lot that's available. And yeah, I think for us on the high risk components, it's really more a function of who the actual like upstream manufacturer is. What are the available substitutes for it? So what tripped us up with the LED is that there wasn't actually any substitutes. And so some other areas of our components, and a lot of times what we do is we actually create multiple designs of our product that can handle different variants of very similar components. So that way, if one goes out of stock, then boom, we can just go in and it can swap in the other one. So it's really about ones where we go, there's no other option for this component. We have to have it. And then, how many options do we have available for it? And if it's very few or just one, then it's flagged to say, shoot. And we, basically then our finance department says, okay, you need how much cash to de-risk this? And, then you of course have to make a business decision of, yeah, you're going to go ahead and lay out some cash so that these components can sit on a warehouse somewhere so that you make sure you have reliable supply for your customer.
Yeah, that's wild. What a thing where you have to have it, instead of like just in time, you end up having a warehouse full of components you need to de-risk. And that's it's an interesting time and I think a lot of businesses are doing that more generally to make sure that they can keep delivering, even if components are not being reliably available.
Yeah, that's right.
Very interesting.
And I'd say from a procurement standpoint and just sort of, hardware in general, you have to pick what you're prioritizing. And so for Luxonis, there's two things that are top priority. It's quality and it's having supply. And so we're at a stage at a company that not having supply is not an option. We have to be in stock with our components. And quality is the other piece where, the stuff that we deliver has to be really high quality. The things that we sacrifice for that is sometimes we pay a higher cost. And that's where sometimes we procure on the spot market rather than something being planned, for example. And we tolerate a higher cost so long as we can make sure that we're, having great quality and we actually have the reliable supply. And we also sometimes we have to tolerate things being not quite as fast, so long as they're not too much delayed. So it's interesting. At some point later in the journey, we'll actually care about cost, but that time has actually not come yet for us to try to optimize for that.
Yeah, and I hope you build in a healthy margin for everything too, so you have a nice buffer. Like of say you have to pay a little more for some components. I hope that's priced in for this kind of thing too. But yeah, it makes sense. You guys are in very much a scaling, like get everyone using it, refine the ecosystem thing so they can make lots of good stuff with what you're making, in my opinion, or in my estimation of where you guys are.
Yeah,
so
that's right. And we do leave room for it. So for example, I had a call today where one of our engineers said, hey, there's what we think can be a more performant component on the bill of materials. It's going to add like $5 of cost to this product. Should we do it? And the answer is like, yes. It's going to it's going to help our customer win. So like the answer is yes. And, what we do first is we say, okay, let's implement that. And then we'll go later on, we'll try to figure out how to make it so that it doesn't actually cost us, $5 extra.
So you mentioned earlier that you like adding sensors to your systems. What do you think will be the next, do you have other sensors that you're considering adding? And what are some of them?
We've been exploring some options. So things that we've discussed are things like event-based cameras. There are things cool. Like the other things like structured light. In other cases, they're about taking one of our current sensors and just making it a lot more performant or capable. So it could be having a higher resolution. It could be that maybe it has a bigger range of things that it can do. And yeah, we're just in the exploratory phase right now because we've been focused on getting the thermal option and the LiDAR time of flight option out there. And so yeah, we haven't set our next plans yet, but that's some of the stuff that we're exploring.
Yeah, actually tell me a bit about the thermal camera, because that opens up a lot of different applications, I would expect.
Yeah, it does. So some of the cases that our clients seem to be really excited about, some of them are in oil and gas. And so it can be placed somewhere and it could detect a leak, say something that's, hot or cold, that a human wouldn't be able to see. And it can also, in that type of a case, in some other use cases, it can see that equipment is operating at the right temperature. So it could see if maybe a component is overheating. The thermal sensitivity is, I think, about plus or minus 2 Celsius. So you can see it with pretty good accuracy. And then some other things are, for example, in the agricultural use case, we had a conversation with a customer this week doing indoor farming, and they're able to use it to be able to monitor their crop. And then there's been also some interesting use cases. We talked earlier about elderly care. And so there's been some over elderly care where the thermal sensor could be added to vision and you would be able to, tell things at a higher performance rate of things like if there's been a fall or something along those lines.
Oh, interesting. Yeah, because I think the thing with thermal cameras, it makes detecting people very easy.
Correct.
Unless it's super hot outside, like indoors, say, where you have air conditioning, because you have that big differential between the person and the rest of the environment.
Yeah, absolutely. We actually at CES in Las Vegas, like I keep mentioning, we had a demo of the thermal camera, and it's interesting because it's people's skin that just really, you really see it light up because it's so warm. And things like, it's interesting, you're wearing glasses. So when people wearing glasses, it looks like they kind of, the temperature profile is so different. So it looks like they're wearing goggles. Like it looks like they're like Robin from Batman and Robin.
Yep,
and so
totally.
it's interesting there. So when, kind of thermally, like if somebody's wearing a short sleeve shirt and shorts, it's actually kind of easier to detect them than if, say, they're wearing, jeans and a hoodie and
a hazmat suit.
Yeah, exactly. Yeah.
Uh-huh. Yeah, very funny. Yeah, thermal cameras are awesome. That's so exciting that you guys are making it more and more accessible to people. Because like I used the Lepton, or was something like that, one of those in the past. And it was okay. And I think you guys have probably made it even nicer for everything. So super cool.
Yeah, we'd like to hope so. We've learned some stuff along the way. So there's actually some like ITAR regulations, which is like international trade of arms control, of arms regulation or something like that. And it turns out that things like a thermal camera, you can't export to certain places. So we've not had to do this normally with our products, but we've actually had to limit the export of it to NATO plus countries. So it's NATO countries plus a few others that are kind of in the
good
mix
relations.
that are allowed. So we've had some angry customers say like, "Hey, why can't you ship it to our country?" And it's like, "No, this is a hard no. We consulted with an attorney. We got an official decision here, and we absolutely have to comply." So it's been interesting for us because we haven't normally had that type of restriction. But we've learned that it's those regulations are, I guess, in there. They're in place for a reason. So we've learned a lot in that process.
Yeah, that's wild. That's not something you normally think about, but interesting. Yeah, you then have to comply with them. And I guess it's for military applications. Maybe you can see people at night, or I don't know. Why do you think thermal is not allowed, or has these ITAR requirements, or I don't know, limitations, or I don't know how to phrase it.
I think you described it correctly, that there's some applications related to military or maybe more nefarious activities that type of technology would work on. And we're not working on anything that's related to that. However, our device can, it's
could in theory. Yes.
Yeah, it's open playground, right? So you could do a lot of things with it. So, for whatever reason, those regulations were put in place. And it's it applies to kind of a lot of that type of technology that we kind of learned about. So there's different sensors that are out there that we say, that those kind of ITAR regulations are in place for. And so, it's interesting, the resolution of the thermal sensor matters for evaluating that. The hertz, the number of frames per second of that matter, the frequency.
Yep.
So yeah, it's interesting to understand because there's, depending on those knobs over, whether there's restrictions or not. So, it's been interesting to learn about that.
Definitely. Okay. Now, so for those who have listened or watched and are curious and wondering how to get started with Luxonis cameras and devices, where should they go? What kind of resources do you have for them? Where would you point them to?
Yeah, absolutely. So our products are really easy to purchase, really low priced. So we have cameras starting at $99. And if you go to shop.luxonis.com, you can order them. And like I said, we shipped into 112 countries, so around the world. And for, getting started with them, we do have a lot of software details that are available. If you go to our website, luxonis.com, you also have like a GitHub as well. And one thing that's great to kind of brainstorm different ideas, get kind of the creative juices flowing, figure out if you think that that technology can be used for this or that. We actually have a chat bot. It's, ChatGPT 4 power that has been, parses through all of our documentation, all of our forum posts, and it's incredible. So it's chat.luxonis.com, and you can say, hey, this is the application I'm working on. What camera do you recommend? Based on this application, do you think it's possible? Would this be feasible? Would that be feasible? And then later on, if you're working on developing something, if you're running into a blocker, or you want to learn more on something, you can ask it. And what's so great is it's way more patient than any engineer ever will be. So the 20th time you prompt it, it's just as plentiful and happy to answer your question as the first. And it's actually way more creative. It comes up with stuff that a human never would. And what's also nice is you don't have to be embarrassed that you ask it questions that you maybe would feel weird with a human. So for me, I ask some of my dumbest questions I can think of to it, because I know that if I asked it to one of our engineers, they would maybe be annoyed by it. So that's where I point them to kind of maybe get started too.
That's awesome. And so what would you, wrapping up, for all that we've talked about, what do you hope our listeners and watchers take away from this whole interview?
Well, I think from a broad perspective, I think that it's a really exciting time to get to see this technology used across these different industries and used across these exciting use cases. Getting to see something that used to be science fiction and become reality is, really inspiring, and makes it so that it's incredible to be a part of this, wave and be part of this journey. We at Luxonis, we love the community. Yeah, we love our users. And so if there's ever anything that you want to chat about, feel free to reach out to me, reach out to our community. And, I hope everybody enjoyed the listen.
Oh, yeah. All right. Thank you, Bradley.
Thank you.
All right. Bye, everyone.